Hi guys, Ms. Griffin. We're looking at Unit 2, Skills 6A. So there are two parts to this skill, 6A, which talks about a function being positive or negative, and then 6B, which talks about a function increasing or decreasing. Both of them are due today. Okay, so 6A and 6B are due the next time you walk into class. So we've got a little reading here. I want you to just pause your video, complete the reading, highlighting important information, and then we'll talk about it. Alright, so I just went through the reading and highlighted a couple of things. The positive regions of a function are where we are above the x-axis. So again, notice in this picture, positive is above the x-axis. So I always draw myself a little picture with the x-axis and the y-axis if you want it. And I know that anywhere above is going to be positive. Anywhere below is going to be negative. And this goes for the right side of the y's and over here as well. Okay, so above the x-axis positive, below the x-axis negative, and if we are on the x-axis, it is neither positive nor negative. Okay, the x-axis is where y is 0. So we have this little chart here where we see that some functions are positive over everything because everything is above the x-axis. Some functions are entirely below the x-axis, so that means they are entirely negative. And then some functions are both positive and negative depending on where it lies on the graph. This portion of the function is negative, whereas this portion of the function is positive. Okay, and we always talk about the intervals in terms of x's. So that's why this down here says that we want to focus on x values and staying on the x-axis. We always also want to read from left to right along that x-axis. Flip it over and we'll see some examples. So we are tasked with finding the intervals on which the function is positive versus negative. So I just want to remind you that we want to write our intervals based on x values. Ooh, I'm in the highlighter instead of the pen. And these are always along the x-axis. And remember that positive is above the x-axis and negative is below. Oops. And sometimes we have to come up with an interval that has multiple negative parts. Like in this picture, I see that I am negative right here and right here. So that's going to have multiple negative parts or multiple positive parts depending on the function. And so we need to know that we can use this symbol, which means union. I know some of you might be used to that as meaning an or in probability unit, but here this actually means that we're going to do something and something. We're joining them together in union with one another. Okay, so here we've got this first example. We need to list out positive and then negative. So the first thing I always do is find out my x values along the x-axis, and then I even might consider putting those numbers for those x values right there so that I know that I'm focused on them. And then of course going out this way brings me to negative infinity and going out this way brings me to positive infinity. So then the second step I take is to highlight the positive versus negative. So I've already done the negative here in green, so if you have a highlighter or colored pencil, it's going to be super helpful for you. So negative is anywhere in green, and then I'll do the positive here in pink. Okay, so then I have to list the two intervals that are negative and then list the one single interval that is positive. And so when I list them, I always want to use parentheses. And so I notice that I read from left to right. Remember that. So I'm reading from the farthest left, so that's the x value of negative infinity, until I hit this the end of the green path at -5. So it's negative from negative infinity on the x's to -5 on the x's. Okay, so I'm going to write that down under the negative section. Negative infinity, comma, -5. But I know it's going to be negative somewhere else, so I'm going to put my little union here. Okay, then I hit from -5, I'm above the x-axis, which means that I'm positive. So from -5 until -3, my y values are positive. Okay, so that's going to be a positive interval from -5 to -3. And notice how I'm using parentheses everywhere, because at actual -5, x equals -5, I am neither positive nor negative because we are lying right on the x-axis. Okay, and then again, I go back down from -3 all the way to the right, forever and ever and ever to the right and downwards. That means we are negative for the y's, and so it's -3 to the positive infinity x value. Okay, and then this is my answer for this first example. All right, let's take a look at this next picture. I'm going to highlight positive again in pink, so that's anywhere above the x-axis. Oops, that's not a highlighter. Anywhere above the x-axis is pink, and anywhere below it is green. And I'm going to list positive and negative. And I'm even going to highlight these words so that I can see exactly what they correspond with on my graph. And then we're going to get going. So we've got positive, let's see, that starts all the way on the left, so negative infinity. And I keep going right until, ooh, notice this dotted thing. This dotted line is called an asymptote. And it acts as a wall. So it's like we can hit this wall, but we can't run through it, kind of thing. Okay, so I'm positive from negative infinity until I hit that wall, and that wall is at x equals 1. So I hit the wall and I have to stop for a minute. Then if I keep moving to the right, remember again we were reading from left moving rightwards, after that wall, I notice that as I move to the right, I'm actually down in the negatives now for the y values. X values are now positive, but it's y values that I'm looking at for positive versus negative. So to the right of that wall, which starts at 1, moving on forever and ever and ever, I'm actually negative. So negative starts at 1 and goes on forever. And then this is our answer for the second example. And there's something that I want you guys to notice here. When I look at this first example, I go back to it, I start on the far left, negative infinity, and I go till -5. And then I notice that the positive part picks up where I left off, -5, and it goes till -3. And then I notice that the negative part picks back up where I left off in the positives, -3 until infinity. Same thing can apply to this problem, the second example. Start at negative infinity on the far left, go until I hit that asymptote at 1, the wall, the barrier, however you want to call it, but the real math word is asymptote. Hit the asymptote at 1, and then I notice that the negative picks up at 1, right where I left off, and goes till infinity. So you should never have gaps in your numbers. They should always pick up where the other one left off. And sometimes it could be positive picking up here with positive, where it left off because maybe, I don't know, you're above the x-axis. I wanted to write something, but all of this stuff just moved. Okay, give me a second. Okay, now I can move. So I wanted to write down here that we want to notice where one leaves off, the other fills in the gap. I'm going to put gap in parentheses or in quotation marks, and picks up. So again, this is something that we noticed about our intervals. When one leaves off, the other one, another interval picks up and fills in the gap so that there are no gaps. All right, third example, last one. Notice that they give us the real zeros here. That's because right here where I have my x value and right here where I have my x value, they are not whole numbers. So they are telling you that this one's at 2.2 and this one's at 0.4. Remember, first step is find your x values along the x-axis. I could not do that in example 2 because they weren't hitting the x-axis at all. But I did define that the asymptote was at x equals 1. Okay, and then I'm going to go and highlight pink is positive, green is negative. I'm going to write out my two intervals, positive, and then negative. And then we're going to list them. So positive is from, let's see, well, actually, let me read from left to right. I should stick with that. Reading from left side, well, this technically keeps going. Furthest to the left is negative infinity. And it stays negative all the way until I hit 0.4. So negative from negative infinity to 0.4. I know that there's going to be another negative interval, so I'm going to just set that up right now. And I know that there is one positive interval. I left off at 0.4, so I've got to pick up at 0.4. When I move rightwards, this graph goes up, of course, but as I move right from 0.4, I then land at 2.2 as a positive part of the function. So 0.4 to 2.2 is positive. And then from 2.2 moving onwards to positive infinity, we are in the negatives, meaning below that x-axis. Okay, and then this is our answer for the third example. And of course, you want to be filling out your summary. Make sure that you fill in the blanks here. We use blank values, so that's like x or y, to write the positive, negative intervals along with parentheses. A graph is determined as positive when it lies blank, like above or below the blank axis. Okay, so you're just filling in the blanks here and making sure you really understand the concepts that we talked about. And then also, don't forget, you have to go watch 2.6b video. Okay, because these, I believe, are due on the same day unless your pacing guide tells you something different.